I am asked to find the term independent of x, or in other words, it is asking me to find a constant term in the expansion of this binomial. Now, if I want to find a constant term by trying to expand this one, it is going to be a lengthy kind of work that I need to do. So I have to find a way that is more easier. One of the sort of approach you can take is using the general formula. Okay, the general formula. The general formula is TR plus 1 is equal to n on R. I have a to the power of n minus r, b to the power of r. This is the general formula for a binomial series or binomial expansion. Okay, so with this formula, I will now extract values and then do the substitution. So let's extract the values now. We collect data, in other words. Okay, n is equal to 12. N is 12. Okay, and then r is, we don't know the value of r. Okay, let's say a is equal to 2x squared and b is equal to 1 over or negative 1 on x. Okay, we have to be very, very careful with negative here. So b is now equal to negative 1 over x. These are the terms, these are the values or the data that we have collected. Now we will substitute into the general term. R plus 1 is equal to n is 12. R we don't know. Then a to the power of n minus 1, a is 2x squared to the power of 12 minus r. B is negative 1 on x to the power of r. Then I will have 12 on r here. And then we have, I will have to separate this one. And that will be 2 to the power of 12 minus r multiplied by x to the power of 2 times 12 minus r. You have to be very, very careful here. When we do the expansion, you have to be very, very careful. Multiplied by negative 1 to the power of r, multiplied by 1 on x to the power of r. So from this stage coming to this one here, you will have to be very, very careful. Now I have 12 on r, and then here I will have 2 to the power of 12 minus r multiplied by 1, negative 1 to the power of r multiplied by x to the power of, let's expand this one. 2 times 12 gives me 24 minus 2r multiplied by x to the power of negative r. I bring this r up. Okay? And then I will have 12 on r, 2 to the power of 12 minus r multiplied by negative 1 to the power of r. Now, we have the same base, so we add the powers. So x to the power of 24 minus 2r minus r. Okay, now I have 12 on r, and then I have 2 to the power of 12 minus r multiplied by negative 1 to the power of r multiplied by x. Now, this is the important part here. 24 minus 2r minus r gives me 24 minus 3r. Now, from here, you will not go anyway. You will have to remember a statement that will help you to take the next step to solve. Okay? And the statement is, for a constant term, the power of x is 0. Based on this statement, I will now say, therefore, 24 minus 3r is equal to 0. And 24 is equal to 3r. I divide 3 on both sides. And therefore, r is now equal to 8. And r is now equal to 8. Once I get the value of r equal to 8, the next thing I will do is substituting r equal to 8 back into the general term, and I should get the term independent of x. 1 is equal to 12 on 8, and then I will have 2 to the power of, I can do the substitution from here, 2 to the power of 12 minus 8, multiplied by negative 1 to the power of 8, and then here x to the power of multiplied by x to the power of 24 minus 3 times 8. You will see that gives you 24 minus 24, 0, huh? 0 power of 0, so you have 12 on 8, and then we have 2 to the power of 12 minus 8 is 4. And then negative 1 to the power of 8 is just 1. And then x will be to the power of 24 minus 24, it gives 0. So we have 12 on 8. Multiplied by 2 to the power of 4 is 16. And x to the power of 0. So 12 on 8, what do we get for 12 on 8? So 12 on 8 is 495 times 16. X to the power of 0 is just 1. So 495 times 16, we have 7,690. And therefore, the 910 is 7,690, which is the constant term. Oh, I have no